Okay. Okay, that's fine. Let's do it like this. And then for here, let's see, what do we have? Start at the bottom. All right. So I hope everyone's doing well. Uh, so this will be our game plan. Let me see. So a kind of recap. So last weekend, from about Wednesday till Saturday, exam two was available on Pearson. It was due this past Saturday, but you can actually work on it past the deadline with a 10% late penalty. So you can get whatever score you want on nearly any score you want on nearly all the assignments at nearly any point throughout the semester. Um, but yeah, the recommendation is to get assignments submitted timely. Get assignments submitted timely. Come on. Come on. Thank you. So that way we don't have we minimize on like trouble. If when we procrastinate with the assignments with Pearson, what I've noticed is that as we get closer to the end of the semester, Pearson is just going to stop working. Like because I guess all the campuses have everything due like at the same time, so it kind of like crashes their servers. So as we get closer to the end of the semester, it's not really going to work that well. So the recommendation is to be as current as possible. Okay, to stay current. Um, so that way, when we get to the end, you've done everything that you need to do, and you're not trying to cram. If you try to cram, it's a good chance that it's just not going to work. Recommendation is to stay current. Yeah, this new system actually works really well. Okay. Always evolving, always upgrading, always improving the craft. Anyway, so that's a little spill on our work. The main setup for our class, mainly get our work submitted timely on Pearson, stay current on Alex. Alex is 10% of our grade. Pearson is 90%. Um, and then just check in at each class. That's all you really have to do. Just make sure you get your assignment submitted, and you have support. You have a lot of support. I want you to all. I want everyone to be aware that you've already paid for tutors. Tutors are included in the tuition at Morehouse. You would just, I would say, maybe contact the math division and the math office and ask them how do you connect with the tutors. And what I would anticipate is that the tutors will have like Zoom accounts available, and you will schedule and you will meet with them. And they have hours. You don't once you get hold of somebody's office hours, you don't really have to schedule. You just show up during those times. Um, mine is probably best to contact me, but yeah, yeah, because my schedule is like very dynamic, and it's like things that are out of my control. But just contact me, and a lot of times the way we have our setup, we often have a lot of class time where you can actually like get tutoring during class from me directly. So that's the idea behind this setup and why we have so much time. So my goal for today, what I was thinking that we could do, one, I wanted to just go ahead and finish out section 2.1 today. So it'll be a little intense. You just have to do the best you can. Keep in mind that this is a recording, so you can always go to my YouTube channel and pause the video, rewind, all that kind of stuff, and watch it at your leisure. Also, a good idea is to watch my sessions with the other classes, because I'll do the same question, but whenever I'm conscious of it, I'll try to work it a different way. So the way I do things with you all, I try to show an alternate method with my other groups, right? And so I want to say like each session with each class is like unique. Um, there was something else I wanted to mention, but it'll come later. Oh, so the goal for today is to go ahead and finish out section 2.1, We don't meet on Wednesday, and then on Thursday, I'd like to take some time to review some factoring techniques. I don't anticipate to get through all. I have a whole chapter devoted to factoring. I want to just take some time to maybe start making our way through that chapter on factoring, so we can just do a refresher. So we'll use Thursday for that, and then Friday I wanted to take time to just work through the homework for section 2.1. I've been kind of avoiding the homework for 2.1 for right now because I wanted to save that all for Friday, so we have something to do on Friday. Okay, so but again, the goal or intent for today, we want to go ahead and finish out the lecture, the introduction to quadratics lecture for section 2.1. I am monitoring the chat, so if you have questions, feel free to type your questions or inquiries into the chat, and I will address them as they arise as I can. Okay. I feel like I'm missing something. My audio looks good. I don't know what it looks like. I'm not going to worry about it. Let me check this. That looks good. Ali Access Free. I don't even know how to get that menu back up. Let me move you down. Okay, I'm not going to worry about it. All right. So let me see. Did I have that? Okay, that's okay. So in this example, so again, this whole section is all about quadratic functions. This example asks us to sketch the graph of this quadratic. Okay. So let me start by giving myself some paper. Oh, that's what we were working on that assignment. Yeah. Let's just add a page. Let's change the view to seamless. And I want a copy of that stuff. Delete. Okay. I want you to drop right here. Expand. Good. Okay. So then I want to do my paper. Nope. This one. Yep. Paper. I like to write on graph paper. And let's get rid of this. Okay. So we're actually sketch the graph of this. So this is a quadratic in I guess we can go like this. This is a quadratic in standard form, so it automatically kind of tells us the coordinates of the vertex. This says that our vertex, which is our h comma k, we do have to change the sign of the h, so it's going to be -2 comma 12. Okay, so our vertex is going to be -2, 12. Now that we have the vertex and we have some other information, we see that the parabola opens downward because the leading coefficient is negative. Okay, so we're anticipating a downward facing parabola. So let me let's make some coordinate axes. So we'll make this be the x-axis. The positive x is going in this direction. Positive y is going in this direction. Okay. Let's label these. So here's the origin. Actually, before we do that, okay, that looks good. And we're just going to get a copy of those. Let's copy, paste. That's decent. Get rid of you. Paste. And then what I want to do, flip those. Copy. Paste. How many do I need? 1, 2, 3, 4. Let's do 5. 2, 4, 5 is these guys. That looks good. We need 1, 2 for there. Oops. Okay, that looks good. Okay, then let's label the axes. So this is the origin. This can go 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. These are all negative over here. Okay. And I think for the y-axis, I'm going to go by 2's. I'm going to say 2, 4. These are negative. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 24, 26. Okay. So if we plot this vertex being negative 2, 12, so if we go left to, and I actually like to graph like this. Let's go paper like this. So negative 2 and 12 is here. Okay. We probably could have gone by ones, but this is fine. So this identifies our axis of symmetry, right? It's going to be here. Style. I usually like it about there and kind of like this one. Right up there. Okay, that's our axis of symmetry. That's going to be x equals negative 2. And then basically whenever we get a point on the left, we automatically get a point on the right. So what I'm going to do, I am going to use my calculator to generate these points, right? So let me open up my calculator. Okay, let's clear. I want to clear this off as well. Okay, let's pull up the calculator. So now the original. Okay, so in the upper left-hand corner, I'm going to click the y equals. We got this negative 3 parentheses x plus 2 squared plus 12, right? So we can confirm that when x is, I'm going to quit. Then now if we look at the clear button, to the left of the clear button is a button that says VARS. I think it stands for variables. I'm going to click on that. I'm going to go to the right to go to y variables. I'm going to click on number 1 for function and number 1 to call that function that we just typed in. So now, first I want to confirm when x is negative 2, y should be 12. Then I want to see when x is negative 1, see what the result is. It's 9, so I'm going to plot that point. So when x is negative 1, ooh, I'm about to let that person in. When x is negative 1, y is 9, so we have a point here. Now, if we go 1 to the right of the axis of symmetry, we're at 9. That means if we go 1 to the left, we're also at 9, right? That's how you use the axis of symmetry. Whenever we get 1 point on one side, we automatically get a point on the other. Let's see when x is 0, what result do we get? When x is 0, we get 0, so it passes through the origin. So if we go 2 to the right, I'm not trying to do that right now. Just go away. Yeah, remind me later. So if we go 2 to the right, we should be at the origin. If we go 2 to the left, 1, 2, we're at negative 4. I think if we try 1, we go off of our chart. So, and then we just connect those points with a smooth curve. And what I'm going to do, like that. Does it pass through my points? Almost. Let's try this one, and then let's see. I don't like that. Okay, thank you.
Professor, can you explain the graphing with the calculator again?
Graphing with the calculator?
I mean, the plotting of the points, getting the points from the calculator.
Okay, give me a moment. Oh, how did I get those?
Yes.
Okay. Give me just a moment. Let's do. I'm gonna make these arrows. That looks good, and this one, the arrow. That looks good. Okay. Let's go like this. The paper, like this. Okay. And let's recap how we got some of this stuff. Okay. Oh, and then one other thing. Let whoever that is in the waiting room, let me let him in. Who's in the waiting room? Man, I need you to get here a little bit earlier. Let's go. Let me do this. Give me just a moment. I'm gonna update the grade book. I mean the attendance. Hopefully it's still working. Give me a moment. It's just Blackboard is moving a little bit slow. Hopefully everybody got their. Look, he's in there. Let me just check something. I just want to see if I'm missing some people. Let me see. Is either Mr. Turner, Jay Jones, James, Mr. Hamilton, K Brown? Are you guys here? Any of those names that I just called? If not, I think we're okay. All right.
I'm here.
Who said that?
Turner.
Which Turner? What's your first name?
Jalen.
Okay. Why is that not showing? What if I go like this? Okay, then I can suppress it. Oh, is that why that's not showing? That's not fair. Okay, I'm not gonna worry about that. Then we got somebody in the later room. Okay. Let me see. Yeah. Okay. I think we're okay. So it looks like I'm missing a couple, but it's not too bad. All right, I'm gonna let that be. Okay, so let's recap how we got some of the stuff. Here, pull up the calculator again. This one. Okay. So what I did in the upper left-hand corner at this y equals, I started there, right? I went on to I clicked on that and I typed this. This is basically the original. -3 parentheses x plus 2 close parentheses squared plus 12. That came from the original. Then to basically, I just plugged in. I called the function and I plugged in the different x values, right? So if I quit, then to the left of the clear button is this button that says VARS. I want to click on that button. It stands for variables, in my opinion. I want to go to the right to go to Y variables. I want to click on number 1 for functions. And I'm going to click on number 1 again to call the function I just typed in. Right? That's how I get there. I did an open parentheses, and then I tested out the -2 first. When x is -2, y should be 12. So when x is -2, our output is 12. Then I did when x was -1. So I just hit second enter to recall what I just typed. And then when x was -1, and then I hit enter, the y was 9. Right? And so then to use the axis of symmetry, what this is saying is basically if we go one step to the right, we're at 9. If we go one step to the left, we're also at 9. So that's how we can use the axis of symmetry to generate several points. Then I said, okay, well, let x be 0. Right? -0 is still 0. When x was 0, y is 0. So that's saying if I go 2 to the right, I'm at 0. If I go 2 to the left, I'm also at a y value of 0. Right? And then when x was 1, that goes off of our chart. Okay? So the x's I tested were -2, -1, and 0, and I got all 5 of these points from just those 3 x values. Okay. Hopefully that answered the question. Okay. So I feel good about that. Let's switch our view back to a single page. Okay. And keep in mind, all the stuff that you see me writing, I'll make it available on in our shared box folder. I'll make all this stuff that you see me writing available on our shared box folder, and like all our past sessions should be there as well. So I usually load a copy of the PDF there, and you can actually pull the stuff that you see me writing. Okay. So notice that the leading coefficient was negative. The x coordinate of the vertex was -2. The y coordinate of the vertex was 12. So that means we had the vertex and the parabola opens down because the leading coefficient was negative. Long story short, I think they get the same results that we got. Now they took the time to identify the x-intercepts and the y-intercepts, but we found them as well. Okay, but they exclusively found those points. We found several, and we use the axis of symmetry to generate several points. Okay, but I think we got the same graph. So we're actually sketch a graph for this one. So now in that last example, The last example was already in standard form. This one is in the general form. So with my earlier class, I did a demo on completeness square. So for you all, I'm going to do what I feel like is easier, and I'm going to use the vertex formula to find this. If you want to see a demo on this example on completeness square, you have to watch my YouTube video from my earlier class, the one that was at 350 from today. Basically the one right before you guys. So we're going to sketch this graph, but we're going to use the vertex formula to sketch this one. Okay? Which in my opinion is easier than completeness square, but it definitely helps to be able to complete the square, right? That's the idea there. Seamless. Okay, so let's start by, I want to get a copy of the original. Getting rid of this. I mean, I'm not going to lie. I'm kind of excited about this remote learning. That's always been a goal or a dream of mine. This is just kind of a random tangent. Just kind of picking up at a conversation that's going on in my head instead of giving you all the details and just kind of giving you what's relevant. But I've always like wanted to be able to teach remotely. Like the idea was that I could teach remote and then be someplace I want to be, and then let me see, paper. So then, like when we would finish class, I would just like shut everything down, and I'm like already on the beach or wherever it is I want to be. And so I'm kind of halfway there. You know, it's unfortunate that it had to take all of this like chaos, but I've realized that one of my abilities is to put a spin on things. I know how to see the silver lining in nearly any situation. Okay, so we're actually sketch the graph for this. Now, normally, one technique is to use completeness square to write this in standard form. But instead of doing that, we're going to use the vertex formula, right? Vertex formula. Okay, I think we mentioned this last time. So the vertex formula, the x coordinate of the vertex, which is our h, is going to be negative b over 2a, right? So from here, we can do this. This is fine. You should see that our a is 2, our b is 8, and our c is negative 10, right? So then that means that ours is going to be, again, our negative b, so that's going to be negative 8 over 2 times our a is 2. 8 divided by 4, that's ultimately going to be negative 2. Okay, so that's the x coordinate of the vertex. Then the y coordinate of the vertex, which is our k, is basically going to be f of h. So whatever answer we just found, we're going to pass it through the function to see what output we get. So then we're going to do, so if we do f of negative 2, that's going to be 2 times negative 2 squared plus 8 times negative 2 minus 10. Okay. 4 times 2, did I write that right? 4 times 2 is what, 8? 8 times 2 is going to be a negative 16 minus 10. That's a negative 8, so it looks like it's going to be negative 18. Okay. So the coordinates of the vertex are h comma k look like it's going to be negative 2 comma negative 18. The leading, we don't need a box there. The leading coefficient is positive, so the parabola should open upward, right? So let me give myself some space and make some more graph paper. We said what, negative 2, negative 18, and it should open upward. Okay. So then what we're going to do, that looks good. This is our positive x. Positive y is about here. So positive y value, and let me just kind of center this a little bit better. Something like that should be okay. Okay, so let's do our labels, our tick marks. Okay, let me get a copy of this. So from there to here. About here. Okay. we need what? 1, 2. So we'll take these two. Oh, that's good. Okay. All right. And then we need to just label it properly. So this is going to be our origin. 1, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7, 8. These are all negative. Okay. On the y-axis, I'm going to go by 2s. So 2, 4, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28. And these are negative values. Okay. So now, we said our vertex occurs at -2, -18. All right. And let's do paper. I usually like this for graphing. So -2, -18. I always lose it right there, right about here. Can you relax? There ain't nothing out there. Hey, what? That's distracting. Thank you. It's probably. I bet you it's a squirrel. She's losing her mind. I know she can see a squirrel. The squirrel's probably just taunting her, like wagging his tail, scooping up nuts. I know it's driving her nuts. Hey, come here, come here. But if it's driving her nuts, it's driving me nuts. Come on, I need you to relax. Come on. Come here. Let's cut it out. Come on. Can you relax? Don't go barking at the squirrel. I need you to chill. Okay. Go to bed. Go to bed. Just relax. Thank you. All right. So we have the vertex. The parabola opens. If we look at the original, the leading coefficient is positive, so it opens up. So this is our vertex. That means we can identify our axis of symmetry, right? So axis of symmetry. I didn't erase anything cool. It's here. Okay. Style. Let's do like this. Let's do like this. Maybe like this. So that's our axis of symmetry, right? So then whenever we get a point on one side, we automatically get a point on the other. So if this is when x is -2, let's see what happens when x is -1. Let me see the original again. There's the original, okay. So then I'm also gonna open up my trusty dusty rusty calculator. Okay, I'm gonna go to my y equals. The original is 2x squared plus 8x minus 10. Okay. So let me quit, and I just want to call on that function. So I just want to confirm that when x is -2, y is -18. Okay. So then when x is -1, we get -16. Let me plot that point. So when x is -1, we're at -16. It's about here. But that means if we go 1 to the right, we're at -16. So if we go 1 to the left, we're also at -16. Let's do when x is 0. When x is 0, y is -10. So that if we go 2 to the right, we're at -10. If we go 2 to the left, 1, 2, we're also at -10. So again, whenever we get a point on one side, we automatically get a point on the other. Let's see when x is 1. So when x is 1, we get 0. So if we go 3 to the right, we're at 0. If we go 3 to the left, 1, 2, 3 is here. We're also at 0. Yeah, I know. So this is kind of eerie. I'm part of like an app. It's called the Pattern app, and it's basically like astrology stuff. But it's just like the advice it be given. It's almost as if some entity is just watching me and like recording what I'm thinking. I'm like, I didn't tell anybody that. How does it know this? It kind of freaks me out, but it's kind of fun at the same time. It's an app called the Pattern app. Okay, let's finish this out. So we want to connect these dots with a smooth curve. Because I'm asleep. I'm totally not getting that song right. Let's go about here. Let's try that one. That's yours. Let's go here. A little bit higher. I think that's good about there. And then let's see if it'll work. Looks pretty good. Oh, it's off. So let's move you like this way. That's right on. So let's move you about there. You about there. That's one over. I'm just trying to get these to like line up, and they're not lining up. Mhm. Okay, that works. That hits the points. That's close enough. Okay. Oh, and then I need to introduce arrows. That looks good. That looks. Oh no. That looks good. Nope. That's fine. Okay. Okay. So that's us doing it by hand. Let me get rid of this. Let me go to paper. I'm watching the clock. We got plenty of time. Okay. So that's us doing it by hand. You saw the construction of every component. Let me go to view, single page. So I think we got the same vertex. So it looks like they just factored, right? They just factored it. They found the x-intercepts, okay? Then they found the y-intercept. They used the axis of symmetry to generate a few more points. So even though we found the x and y intercepts, we were just kind of like finding points and finding the reflection on the axis or whatever. Um, but yeah, finding the y-intercepts, finding the x-intercepts, using the vertex, using the axis of symmetry. These are all techniques that we have for finding graphing parabolas or quadratics. Okay. Okay. Let me see. So now this example, I think we have two more examples left. Once we hit that second one, I'll probably just let us do like work on our assignments for the rest of the class. But it'll take us a little bit of time to get to these two. It should anyway. It says the graph of this is shown. It says find the domain and range of f, right? And then solve this inequality. Basically, when is this graph positive? Or in other words, when is this graph above the x-axis, right? And the answer is actually shown, but you know. Okay, so the domain, right? If we wanted to talk about the domain, style, like this, okay? So the domain of a graph is the very left to the very right. So how far left does this graph go? Going to the far left. No matter how far left we go, we can find a corresponding y for every x going to the left, right? Even though it looks like it doesn't touch, you have to remember that the graph continues the pattern in that direction. Whoops. In this direction, right? And so if you keep going, eventually it'll reach every x going to the left, and there'll be a corresponding y. So the domain being the very left to the very right should be negative infinity to positive infinity. But then when we go to find the range being the very bottom to the very top, how far down does the graph go? The very bottom is negative infinity. No matter how far down we go, we can find, no matter what y value going down, we can find a corresponding x, right? And then the very top, the highest y value looks like it's 3, right there. Highest y value looks like it's 3. So the range is going to go from negative infinity up to 3, and the 3 is going to get a square bracket because we actually do reach y equals 3. Okay? So then we want to solve this inequality. I'm going to get rid of this. Yeah, so let me solve this algebraically. It's a little bit of effort, but basically, once you find the x-intercepts, then it's like, it's saying when is this graph, this one is specifically saying when is it positive. In other words, that means when is it above the x-axis. So we need to solve for those x-intercepts. I would use the quadratic formula here to solve the x-intercepts. Let me start by getting a copy here. Hey, do you need to go to the bathroom? Do you need to go to the bathroom? Huh? Oh, oh, come on. Go ahead. I'll take that as a no because you're not behaving like you normally do when you need to go. But I need you to kind of thank you. Okay. I can't see. Thank you. You can just hang out somewhere. You just want some attention. Thank you. Okay. So quadratic formula, right? Let me make some space. Add a page. I'm watching the clock. I think we're fine there. Let me get a copy of this. Get rid of this. It's hilarious. Hey, go to bed. Go to bed. Go to bed. Go. I need her to kind of chill for like 20 minutes, and then I can let her chase them. She actually almost got a couple of them the other day. I let her out, and they just didn't know she was there. Next thing you know, she was like on their tails, but they always outrun her. Go to bed. Go to bed. Go to bed. So she's not so distracted. It's just like it's not dark. Why you gotta be going to bed? She'll probably be out in like 2 seconds. She's so funny. Let's go paper like this. Okay, that's fine. So now I just want to show you how to solve this inequality algebraically. So since it's a quadratic, you could try to factor it, but you'll probably see quickly that you're not going to be able to factor, right? Because if we were going to factor this, we will be looking for two numbers that will multiply to give us 10 and add to give us 8. And 10 is only 1 and 10, which adds up to 9, or actually positive and positive. It adds up to 11, and then 2 and 5, which adds up to 7, right? So we can't factor it in that sense, but we can use a quadratic formula here. So again, one of my students, the way they remember it, the negative boy couldn't decide to go to the radical house because he was square, so he missed out on 4 awesome chicks, and it was all over by 2 a.m. I thought it was fantastic. It's like a mini movie. Some students in the past have tried to link the formula to like a song, but every time I try to remember the song, it would change. Sometimes it would be Old McDonald's, sometimes it would be The Saints Go Marching In. I'm like, what's the proper tune? I always will forget the proper tune. But I can remember that story. It sounds like Hangover to me, so that's why I do that. But you don't have to do that. I'm just showing you like some of the ways that people remember these things. So let's identify our A, B, and C. So it looks like our A is -2, our B is 8, and our C is -5. Okay. So then if we plug those in, what's our B? So that's going to be -8 plus or minus the square root of 64 minus 4. What's our A? It's -2. And what's our C is this. Almost done. I'm going to let you run around. 2 times our A is -2. Let's simplify this down some. She's so funny. So dogs make great emotional support animals. If you like ever deal with depression, which is like college, college is, if you have to actively like do things to kind of keep your spirits high. Otherwise, it's very like deterring, overwhelming, depressing. It takes a lot to get through college. It's not for everybody. But if you do have access to an animal like a dog, dogs are great. Like they're great emotional support animals. They will get you through it. Like if you just imagine you talking to a person and you talk to them, they'll just look at you and listen, and they'll be like, okay. And then the way they respond, just be like, why are you responding that way? Sometimes it's like they actually listen. It's really funny. But they'll help you get through stuff. So we got 3 negatives, so that results ultimately going to be negative. 4 times 2 is 8, times 5 is 40. Okay? But yeah. And then that's going to be a -4 on bottom. We're going to have -8 plus or minus, I think that's 24 over -4. 24 is 4 times 6, right? So the square root of 4 is 2. So we can have -8 plus or minus 2 times the square root of 6 over -4. And then we can divide both things on top by, we can divide everything by, looks like -2. All the terms by -2. So that's going to become 4 plus or minus the square root of 6 over 2. I think this is okay. So these are the coordinates of our x-intercepts. Let me add another page. Okay. So what's happening here, we're on the x-axis. All right, positive x is in this direction. And we have our 2 x-intercepts wherever they are. So one of them is going to be this 4 minus the square root of 6 over 2. The other one is going to be 4 plus the square root of 6 over 2. Okay. Oof. So these servers are zeros. So the y values here are going to be 0. If we glance at the original has a negative leading coefficient. So we're anticipating a parabola that opens downwards. So something sort of like this. Something like that. Okay, we're anticipating something like that. Let me do something like this. Let me move this down. Let me go style. I want to do it like this. Let's do thicken it up a bit. That's pretty good. That's okay. And so these x-intercepts break the x-axis up into segments. In this case, it breaks it up into 3 different segments, right? So we got the points that are to the left of this x-intercept. Hang on. Right. Oh, I see it's moved. I see what's going on. Okay, let's do this one. I want that to be lined up. Did I distort it? I didn't distort it. Let me get rid of you. Just move you out of the way. That's there. That'll work. Oh. Okay, that's fine. And she's still intent on barking at whatever's there, whatever she sees. And let's go like this. That's fine. Okay. Copy. So we have the part that's to the left of that first green line. We have the part between these 2 green lines. And we have the part to the right, right? So these key numbers of these x-intercepts break the x-axis up into these 3 segments. So then what we want to do is choose test points in each of these 3 segments. And basically all the y values are going to have the same sign, right? And again, the blue is the kind of graph that we anticipate. So this 4 minus the square root of 6 over 2, that's like 0.7 something, right? I used the calculator before to find that. So then if that's 0.7, if I want to choose something to the left of that to test, so I'm going to choose something like x equals -1. And basically all the y values to the left of that first 0 should have the same sign, either all positive or all negative. Okay, so let's open up our calculator. For the y equals, I think it's the same one. It is not. So let me type the one that we're working with. -2x squared plus 8x minus 5. Okay. So then I'm going to quit. And I just want to call on that function that I just typed in. So to the left of this first x-intercept, I'm going to choose x equals -1. So we're anticipating a negative value, and we indeed got a negative, right? So every y value to the left over here should be below the x-axis. So everything over here is going to be negative. So to choose something between these 2 x-intercepts, I'm going to choose x equals to 1. So we're anticipating a positive result, and we get it. So what it's saying is basically every y value between the x-intercept is positive. And then I'm going to choose something to the right. Let me see what number that is. 4 plus the square root of 6 over 2. I'm just going to type it in. I think I have it. I'm going to try to call it back. Maybe not. Ooh, no, that reset. Okay, let me just type it. So I'm going to do parentheses 4 plus the square root of 6 divided by 2 is like 3. So I'm going to choose when x is 4. So if I let x be 4, we're anticipating a negative result, right? So what that means is that every y value going to the right over here is below the x-axis. So if we go back to the original question asks, when is this positive? In other words, when is it above the x-axis? Well, now we clearly see that the graph is positive or above the x-axis between these intercepts, right? So the solution set that we're going to submit is going to be the interval from 4 minus root 6 over 2 to 4 plus root 6 over 2. If we want it strictly positive, we're going to use parentheses. Right? We use parentheses because there's no equal to bar here, so that's why I use parentheses. Okay, that takes practice. You know, this kind of thing takes practice. At this stage, I mean, it intimidates a lot of students and it's overwhelming, but just maximize your experience with this whole remote thing, right? Keep in mind, again, you've already paid for tutors. I'm available. Make use of the Ask My Instructor. So as you kind of like work through examples, if you get stuck, uh, my recommendation for the order in which you should ask for help, my recommendation would be first do what you can on your own with whatever research and using Pearson, and then once you've kind of done what you feel like you can do on your own, if you like work with any of your classmates, either remotely or however, then I would try to team up with some of your classmates. If you can't find anybody, it's okay. Because then next, after your classmates, I would target like the tutors. Remember, you've already paid for tutors, so get your money's worth out of them. A lot of times they're just sitting there waiting to help people. And then after you've done what you can on your own, you've done what you can with your classmates, and you've done what you can with the tutor. That's the ideal time to come to me. If you come to me first, often what happens is that it's like information overload, and the students are just like they just give up, right? But when you've gone through those different protocols, then by the time you ask me the question and I give the exact same presentation, it usually sinks in a lot better for students. It's very clear. The click, you're like, oh, they're like, oh, I get it now. It's like I was wasting all this time doing this. But the thing is, you do have to be frustrated a little bit for it to click, right? If you're never frustrated, you're just gonna be frustrated. I know that's kind of a loaded statement, but yeah, you do have to be frustrated a little bit for it to click. We got about 25 minutes, give or take. So we got one more example that we need to do. I think this one looks good. Let me go to view, let me go to single page, and let me get rid of this graph paper. Okay. And they essentially got, again, the graph is above the x-axis between these two x-intercepts, right? They probably looked at the graph, but I showed you how to find it if we didn't see the graph, right? Okay. Basically find the intercepts. The x-intercepts break the number line up into segments, and you just choose it. You test the point. Everything to the left of that first intercept is negative. Everything between the intercepts in this case ended up being positive, and everything to the right of that second x-intercept ended up being negative again. Right. So we wanted to know when is it positive, basically between these two x-intercepts. Okay. All right. Not home free, but this is the last one that we'll do for today, and then I'll let you take a break. We can breathe a bit. Okay, but we do have our work cut out for us. Okay, but it's totally doable. You have to get over the intimidation factor. You have to get past that, and you say, you just keep going until. And I just also want you to be aware that no matter what happens, good, bad, or indifferent, there's always a way. Everything is going to be fine. Like, I don't want you to think that like whatever you think is the worst thing in your college experience. Know that as long as you have breath in your body, there's always a way to get things done. I know plenty of people that quote unquote did not finish school, like they did get their degree, but they're doing way better than everybody else, right? And then I know people that got the degree can't get it together, right? So it's there's nothing set in stone that says this is what it's going to be. I'm just trying to help. Our goal, I don't know if I can speak for the other professors, but I know my personal goal is to just try to help as many people as I can on their way. And all I do is kind of write down what you guys are doing, at least on my end, what I see, and then I call it a day. But ultimately, your experience is going to be left up to you. If you want to have a great experience, it's ultimately up to you. Uh, it doesn't matter which route you go, your experience is your own. You just have to be accountable for your experience. If you're not liking your results, you can't blame. You can blame people all you want, but they're not going to do anything different. The best thing is if you don't like your experience, you got to do something different. You got to think differently. Really, that's the biggest thing is you got to think differently. You got to do something different. You got to take charge, take accountability for your experience. Say, hey, I'm not liking this. Let me not blame nobody. Let me just see what can I do on my end to improve my experience. If you like what you're experiencing, it even though you have help, ultimately it still is up to you. Like you took the time to be patient, to take action, to do what you needed to do to create whatever experience you're having. So everybody's experiencing is their own responsibility. As much as I try to blame either ex-lovers or professors or people in my life or non-people in my life, as much as I try to blame others, at the end of the day, I do know that my experience has nothing. It's not their control. It's up to me. It depends on how I choose to respond to things, if I respond at all. Um, but my experience is my responsibility. It's not the president's. It's not other races. It's not school or academia. It's nobody else's fault or glory. It's all me. When it comes to me, other people, I try to help them, but ultimately, I don't know. It depends. It just depends on a lot of different factors. If I'm going to be teaching, so there's a question that arose that says, do we have this class next semester or does it change? It should change. If you pass the class, then after college algebra, it depends on your track. One like every student in most schools, you have to have at least two maths. So after college algebra, it can be anything like applied statistics or finite math or pre-cal or whatever. But usually, if you're going into the sciences, like any kind of science, your program will tell you how high you need to go in math. If you're going to any kind of science, usually you got to do pre-cal, cal, and at least cal one for many of the sciences, and some go a little bit higher. Um, and I honestly teach from calculus 3 on down. I've taught up to calculus 3, and I've taught a few around those, but highest is calculus 3 for me that I've taught. Um, but yeah, that's the long and short of that. So I'm going to do my best to try to wrap up this next example in about 10 minutes. So as soon as I finish this one, especially if we finish around about 10 minutes from now, I'll probably let everybody go. Okay. Thanks for letting me be on the soapbox and just indulging me. Just trying to share my experience, and hopefully you guys can take it, put your own personal spin on it. And even though pain and suffering is nearly unavoidable, it seems like everybody suffers, but it just seems like some people have style and class. Even though they suffer, they have to work hard and all this, but they seem like they at least get moments where they can like buy what they want, go where they want, do what they want. They're free on some level, but everybody has to suffer. Everybody on this planet seems like they go through some kind of pain and whatever. But you decide which end of the spectrum you want to be on. You want to be on the luxurious side, but you still got to suffer, or you want to be on the dilapidated side, but you still got to suffer. See what I'm saying? So it's like that's been my experience. But anyway, okay, let's look at this last example. So we're actually it says to find the dimensions of a rectangular garden of maximum area if the perimeter of the garden is 80 feet. What is the maximum area of each rectangle? Okay, let x be this, let x be the width, and let y be the length. Okay, so it says a rectangular garden. Let's go paper, graph paper. So it's probably a good idea to draw a relevant shape. Are you messing up on me? So relevant shape is going to be a rectangle, right? So let's start with a rectangle. Okay. Let's go back and see what else do we have. It says find the dimensions of a rectangular garden of maximum area. It says the perimeter of the garden is 80. So it says the perimeter is 80, and we want to maximize the area. Okay. So if we have a rectangle, what's the formula for finding the perimeter of a rectangle? I just want you to think about that for a moment. So that's actually kind of a bait question. There's not a set formula for perimeter, and I really wish I hadn't used the word rectangle. But in general, perimeter is just the distance around the outside of the shape. So the shape is going to determine the quote unquote formula. If it's a triangle, then when you add up all the sides, it kind of changes a bit. But for a rectangle, it said let x be the width. Just let x be w. I'll do it like this: the width, th. Right? And let y be the length. Okay. So perimeter of a rectangle, if we add up all the sides, that's basically going to be 2x plus 2y equals, the perimeter in this case is 80, right? So also, if we wanted to find the area of a rectangle, that's going to be the length times the width. So this is basically going to be x times y, right? So if we want to get the area in terms of one variable, let's solve for y in the first equation and then plug that into the second equation, right? So if we take the first equation, which is this 2x plus 2y equal to 80, and we solve for y, so I'm going to subtract 2x on both sides. So then we get 80 minus 2x. Divide both sides by 2. We get y equals 40 minus x, right? Then we're going to take that 40 minus x and plug it into the area formula. Okay. So we're going to take that y equals 40 minus x and plug it into the area formula. So then now we should have the area is going to be x times y, which is 40 minus x. So now we have an expression for area in terms of x, right? And we're asked to maximize the area, right? Let's kind of expand this out and see what it looks like. So our area in terms of x, if we distribute here, I'm going to distribute and kind of rearrange it a bit. We're going to get negative x squared plus 40x, right? So this should look familiar to something that we're doing all day, right? Notice the highest exponent is 2. So the graph of this should be a parabola. And because the leading coefficient is negative, the parabola should open downward. So if we have a downward facing parabola and we want to maximize, what concept or what part of the parabola will the maximum occur? So if we have a downward facing parabola, the maximum should occur at the vertex, right? So we have a formula to jump straight to the vertex, okay? So for the vertex, the x-coordinate of the vertex, which is going to be our h, is going to be negative b over 2a. She has nothing else to do, so I'm not even mad at her. I'm just trying to help her to not be such a distraction so we can focus and do what we need to do and keep it moving. But she's doing her job. As long as she's not peeing and pooping in the house, she's doing her job. I can deal with the rest of it. That peeing and pooping, it's going to be trouble. we're gonna fight. But so I just need to let her out so she can relieve herself. But anyway, she wanted to chase the squirrels. Hey! Give me like 5 minutes. Come here. Come on. Can you cut that out for like 5 minutes? Just give me 5 minutes. Come on. Give me 5 minutes. All right. So our b in this case, so if we're going to do negative b, that's going to be negative 40 over, a is negative 1. So that's going to be a positive 20. That's the x-coordinate of our vertex. If we want the y-coordinate of our vertex, which is the k, we're going to do f of whatever answer we just found, right? So in this case, we're going to say f of 20, and the original, or I guess in this case it would be a of 20. Let me just kind of write the proper thing there. A of 20. So that's going to be negative x squared plus 40 times x, but the x in this case is 20. Okay. So then that's going to be what? Negative 400 plus 800 equals 400, right? So the coordinates of the vertex are going to be 20, 20, 400. Okay, so those are the coordinates of the vertex. So our claim is that the maximum. Let me call you back in like 5 minutes.
Okay.
All right. So we said the area is going to be maximized at the vertex. The coordinates of the vertex were 20 and 400. So when x is 20, the maximum area is going to be 400 square feet. So then we got that x was 20 feet. So then we need to go and find y. Y is going to be 40 minus 20, which is going to also be 20 feet. Okay. I think we're ready to answer the question now. It says, "What's the maximum? Find the dimensions of a rectangular garden. What is the maximum area?" So when x is 20 feet, or and y is also 20 feet. So when the width is 20, and that's not feet. The length is also 20 feet. Then the max area, I think we got was 400 square feet. So feet squared. Okay. Basically this stuff here. Put you like there. Let's do like this. Let's do style. We're gonna thicken you up. That's fine. And then I'm gonna shrink this stuff down to size. I want you about there. That's good enough for me. Okay. Let me do like this. Let's go paper. We're right on the money. 20 by 20 with a max area of 400 square feet. Okay. Now again, all this work that you see me writing, I'm going to load a copy on our Blackboard page. If you go to our Blackboard page at the bottom, folder number 7 says box. You click in there, you can find all of our notes in that link. Right. So the maximum area of the rectangle is going to be 400 square feet, which is a 20 by 20. So it's really a square. It's going to be maximized when we do a square. Okay. All right, let me go ahead and load a copy of these notes so I don't forget to do that. If I go here to box, 2020, more house, folder number 3, into the notes, and yes, right? I can't really think of any. If there aren't any burning questions, we're actually going to end the session here. And from one beautiful mind to another, enjoy the rest of your day. Thank you guys for being awesome. You are awesome. Keep up the good work, and I will see everybody Thursday at 3:15. Okay, enjoy the rest of your day. Take care, guys. See ya. All right, you're free. Go ahead. You want to scream? Go ahead. Go bark. Go crazy. Go ahead. You got a few minutes since I got to go.